the potential difference across two ends of a conductor is directly proportional to the current flowing through the conductor under, very important to mention, under constant temperature, pressure and other physical conditions. Now this is the complete statement of Ohm's law. So whenever you are going to write statement of Ohm's law, it is very important to mention that condition. Now this is the Ohm's law. In this way you can state Ohm's law. Now second is, because there is a proportional relationship between potential difference and conductor, that is V is directly proportional to I, that is V upon R, that is V upon I is equal to R. Now if we draw the graph between V and I, now what will be the graph? Very simple, that is linear graph. Linear graph means if we are taking this is V and this is I, then according to this the graph must be straight line. Of course it is a straight line because it is directly proportional relationship. Now from this graph, how can we find out the resistance? Now we can see here, if we take slope of this graph, what will be the slope? Slope is nothing. What is slope? Slope is nothing. Slope is nothing but only we can make use. Suppose we are taking 2 points. This is first condition. Suppose this is V1. Suppose this is I1. Similarly, this is V2 and this is I2. Now slope. Slope is nothing but tangent. Slope is equal to, that is V2 minus V1 divided by I2 minus I1. So this can be written as delta V upon delta I. So this is nothing, delta V upon delta I. This is nothing, this is slope. And from this relation we can say that this is nothing but tells about the resistance. It tells about the resistance of conductor. So therefore, if we have given VI graph for two conductors having different slope, then question can be asked for which conductor the resistance is higher or lower. So by using this concept of slope, we can find the value of resistance for 2 conductor or 3 conductor or 4 conductor. If, for example, let's take example can be taken in this way. Suppose this is VI graph, this is VI graph, this is conductor number B and this is conductor A. This is VI graph. Now in this question, can we find for which conductor resistance is more and for which one the distance is lesser. And we know that just we have find that R is nothing but it is slope, that is delta V upon delta I. Very simple. First we can find out the slope for this. You can see. Don't need to find. Very simple. For this B, the value of P is higher in comparison to this I. Similarly, value of I corresponding to this, value of I corresponding to this. So it is very clear from the graph that for conductor B, the slope is sharp, and for conductor A, the slope is not steeper. So by using this concept, we can say that for conductor B, the resistance is large. So for this, the R is large or higher, and for this, because V is very less, you can see I, therefore we can say that for this R is lesser. R is lesser. R is lesser. So in this way, question can be asked. Very important question. Now next, for all conductor which are good conductor of electricity, Ohm's law is always applicable for those conductor, especially conductor like metals. Now let's come to limitation. Limitation we can take as given in your NCERT textbook. Point number 1. For conductor at higher temperature, Vi relationship is not linear. It is very simple. This is Vi graph for a conductor. Now, at lower temperature, the graph is like this way. At low temperature, that is at low temperature. But what happens if temperature is very high? If temperature is very high, what happens at higher temperature? There is a little deviation. Now we can say that under limitation of Ohm's law, we can say that at lower temperature up to certain range, all the conductors obey Ohm's law, but when temperature rises from that range, the relation will not be purely linear. This is the first advantage. Now, what is the conclusion? For all temperature, the conductors will not obey Ohm's law uniformly. There is a little deviation from that linearity or linear nature of the graph. This is limitation number 1. Second limitation is for semiconducting material. Semiconducting material. The Vi graph I graph is not linear at all. We will discuss actually this relationship between V and I in second part under the chapter semi-conducting devices. Now, it is only for explaining the limitation. We are just taking this into consideration. For example, PN junction, PN junction diode, PN junction diode. It is represented by this way. This is P and this is N. That is, when we combine P and N, we will get a PN junction diode. So this PN junction diode is under forward biasing. Under forward biasing, what will be the graph? The graph is like this way. Graph is like this way. Now we can say that for PN junction diode or for semiconducting material, the Ohm's law will not be obeyed. Similarly, if we are taking this PN junction under reverse bias, again we are not getting linear graph. The graph is like this way. You see the second limitation. So we will take only these two into consideration. We will not take much more. Third limitation is also related to the semiconducting material. If you see NCERT textbook, the third limitation is also given there. So if question is asked that write the at least two limitation of Ohm's law, we can write. First, for conductor, that is at higher temperature the conductor will not obey the linear relationship between V and I. Second, for semiconducting material under two different biasing, the VI relationship is not linear. Or we can say that the semiconducting material does not obey Ohm's law. So sometime question can be asked in this way.